just click start streaming. Testing. Hey, alright. Testing 1, 2, 3. Testing. Testing. Hey. Dang, the audio's so low. Is it me? Testing 1, 2, 3. Testing. Testing. I want to sonido.
Dang, the
1, 2,
audio's
3.
so
Ah.
low. Is it me?
Testing 1, 2, 3. Testing. It's still really low. I don't like how it sounds. Is there a way to boost
I
this?
want
to sonido.
Dang,
1,
the
2, 3.
audio's so
Ah.
low. Is it me?
Testing, testing. 1, 2. It's still really low. I don't like how it sounds. Is there a way to boost
I
this?
want
to sonido. 1, 2, 3.
so
Ah.
low.
Alright, I'll eventually get a headset,
Testing,
but in the
testing. 1,
meantime,
2.
this is what we got. Alright, I'll eventually get a headset,
Testing,
but in the
testing. 1,
meantime,
2.
this is what we got. Okay, okay, okay. The stream is still going live. We're good to go. Let me hit the mirror. Okay, whatever. I'll put it here. This thing's still live, right? It's just not caught up. This thing's still live, right? Okay, dokey, dokey, dokey. Okie dokie. Let me see. I should probably throw this thing on to the side. Yoink. This thing's still live, right? Top chat. I need to test my chat in case I ever need to talk to people. Might as, you know what I mean? Figure it out, because the one person's gonna join on, I'm not gonna be able to help them. Okay. Trig study time. Okay. Big trig. So trigonometry, I actually don't even know what it means exactly, but what it is, it's really the relationship of triangles. So these are the four different equations of relationships you need to understand trig equations. The first one is going to be sine theta is equal to yx, which is really going to be the opposite over hypotenuse. So let me explain. So let me actually start over real quick. But first of all, I want to find out how to spell hypotenuse. 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 Okay, that's close. Okay. So let's just kind of start over real quick. So trigonometry basically is a study that relates a triangle, specifically a right triangle. It relates the properties of a right triangle. So let me explain this. So a right triangle is basically a triangle. Triangles have three angles. Specifically, a right triangle has a right angle, which means it's 90 degrees. And you have the hypotenuse, which is the side opposite of this right angle. The other two ones are side legs of this right triangle. And usually when we're looking at one part of this angle, the we will define the side lengths with respect to this side angle. The side that is on the opposite side of this angle, we're going to call it opposite, or y in this case. And the angle that's next to this, sorry, the side length that's next to this angle that is not the hypotenuse is known as the adjacent leg. And so this one is the hypotenuse. Trigonometry helps to basically relate all four of these. There's something really, really neat. Give me two, and I'll give you the third one, right? Give me the opposite and adjacent, and I could find you the angle. Give me the angle and hypotenuse, I could find you the adjacent. Give me the hypotenuse, adjacent, I'll find you the opposite. So there's four different equations that relate all four of these. The first one relates all of these sides. You've probably heard of it. It's the Pythagorean theorem. It is x squared plus y squared is equal to r squared. I know it's not written exactly like that, but a lot of you have probably seen it as a squared plus b squared is equal to c squared. This is the first equation. This is how you relate all these sides. If I know the opposite and I know the adjacent, I can find the hypotenuse, right? Using this equation, I can solve for it. The second one is the sine relationship. Sine theta is equal to the opposite leg of this angle, theta, over the hypotenuse. Or we'll denote it as y over r. One way to kind of keep this in mind, and we'll go over it in a few, but there's a way to kind of remember this. The third equation of relationship is the cosine of theta. And so this one's going to end up being the adjacent leg over the hypotenuse. This is going to be x over r. The fourth one is a tangent of theta. And so this one's going to be the opposite over the adjacent. Adjacent. Which is going to be y over x. And so now one little like acronym type deal to remember this. You'll hear it so many times. It's SOHCAHTOA. This is to remember the last three equations, 2, 3, and 4. So we have this S right here. We have S. This stands for sine. This O and H are for opposite and hypotenuse. Okay? Then you have cosine, C for the ca, CAH. A for the adjacent, and then over hypotenuse. You see that? Ca. Then next we have tangent. This is the TOA. Remember the TOA. All right. Remember the TOA. I got my little toe right here. I'm gonna cast TOA. TOA. So that's opposite over adjacent. So this, you hear people saying this. You're gonna hear your teacher saying this. SOHCAHTOA. This is to remember this, so you don't forget it. And so, sine, if someone says, hey, I'm giving you the angle and the adjacent one, you need to find y. Right away, you just take this out. I need sine. So, SOH, opposite over adjacent. We're going to do y over r. Sorry, opposite over hypotenuse, y over r, right? So anytime you're given an equation, you're going to be given some triangles. Here, maybe black, you can't see it that well. You're going to be given a triangle. Your instructor is going to give you this. Oh, 37 degrees. You have, this is 2. What is this one? It's A. Right away. What is this? What do we have? Boom. We have an angle. All right, we have an angle. We're going to use one of these 3, okay? We have the bottom one. Sweet. Which one's this one? Is it the hypotenuse? No. It's going to be the adjacent one. So A, okay? What's this one? Opposite. O. So then we're going to need an O. So we have an angle, so it's one of these. We have adjacent. It could only be cosine or tangent. For A, you have the O. AO, the tangent. So what you're going to do is you're going to plug this stuff in. Tangent of 37 degrees is equal to the opposite, so A, over adjacent, 2. So now you do some math to solve for A. You can multiply both sides by 2. And you're going to get A. You have A over 2 times 2, which is equal to A, is equal to 2 times tangent 37 degrees. Okay? And so you plug this into your calculator, and you'll get a value. All right? I guess I should probably do it real quick as well. If you have an iPhone, you have a calculator with you. And one thing you have to make sure to do is make sure that you have it in degrees, not radians. Your calculator will probably say deg or rad. Make sure it's in deg for degrees. 37 degrees. So the answer to this is going to be 1.507. You write however many degrees are necessary, but that's what it is for that. So that's the big important part to keep in mind for trigonometry. If you don't have this down, you're going to struggle. The next is just trying to figure out how to apply this stuff, right? We'll do a quick one with the Pythagorean theorem, okay? If I gave you this 3, 4, and I said, hey, what's this one? You're going to do 3 squared plus 4 squared plus x squared. So then you solve this out. What's 3 squared? It's going to be 9. 3 squared is 3 times 3. Okay, 3 times 3 is 9. Then you do 4 squared. 4 times 4 is 16. You add those together, you get 25. This is equal to x squared. The next part is you're solving for what x squared is by taking the square root of it. Take the square root of x squared, you get x. The square root of 25 is 5. That means this x is equal to 5. So you see, we had those. We were able to find the relationship between those side angles. Let's say we just had 3 and 4, okay? Now we wanted to find the angle, right? So we want to find the angle of this. We actually have all 3 of them, so we can use whatever one we want. We'll just use the 3 and 4 for now, if that's okay. So using the 3 and the 4, again, 3, 4, an angle. what do? We have an angle, so we use one of these. We have the opposite and adjacent, so we're going to use tangent. So we throw it in here. Tangent of theta is equal to the opposite, which is 4, over 3, the adjacent, which is 3. So here is when you need to use the inverse relationship of the trig function. So you're actually going to be using the arctangent. So let me clean it up a little bit. Arctangent of 3 over 4 is equal to theta, or you're going to see it as tangent to the negative 1 power 3 over 4. And so even though I said 3 equations, technically the opposite of these to solve for the angle is the inverse of it. So there's inverse sine y over r. There's inverse cosine x over r. And then there's the tangent one. You could see it as inverse, so that to the minus 1 power. Or you're going to see it as how I have it over here in arc. You'll see arc sine, arc cosine, arc tangent. And so those are the main things you need to know in real life. If you can master those, you'll be set. Okay, now to do some applications. Let's continue this process. So I'm just going to run through a couple different examples, and we're going to try to work them together, okay? Let's say I gave you an angle, and I said this is angle 27 degrees, okay? We note that we can get this one 5, and maybe right here we're going to have it x. So what do? We look at, what do we have? Opposite. So we just reviewed previously was the standard equations you need. You need the Pythagorean theorem and the 3 main trigonometric equations: sine, cosine, theta. You can figure out how these operate using this little acronym of SOHCAHTOA. This helps us remind what we're doing and where we're getting it from. So sine is the opposite over hypotenuse. Opposite means the leg that's opposite of this angle. Hypotenuse means the long angle. It's usually the longest, not angle, the longest side length that's opposite of the right angle. Okay, the right angle is a square box. If you ever see this square, that means 90 degrees and you have a right angle. Okay, so SOHCAHTOA is the opposite to the angle over the hypotenuse, so this long one. Cosine is the adjacent leg next to this angle that isn't the hypotenuse. Both these are adjacent to this angle, but only one of them is not the hypotenuse. And then it's over the hypotenuse. And then TOA is the tangent. That's going to be the opposite over the adjacent. Okay? And so when solving this one, we have opposite and we have hypotenuse. That's sine. SOHCAHTOA. So we just write it. We have sine of 27 degrees is equal to opposite 5 over the hypotenuse. So now when you try to solve this out, you can multiply x by both sides. You get x times sine of 27 degrees over 5. Then you can divide both sides by sine 27 degrees. So that's going to give us x is equal to 5 divided by sine 75 degrees. Oop, 25. I am a little out of it. Good thing I caught it. 5 sine over 27 degrees. So let's plug that into our calculator and see what we get. Pause this right now if you want to work this out yourself. 27. Cuckoo. Nice. What do we get? We got 11.01. So if you got that, you are set. You are good. Okay. And say, for example, that now somehow you want more information. You want to solve for this one. There's a lot of different ways you can go. You have three pieces of information. You can do the cosine. You can set this up. Cosine of 27 is equal to, hypotenuse over, sorry, the b over hypotenuse. That's a very valid way to solve this problem. You can also do it using the relationship of Pythagoras. B squared is equal to 5 squared is equal to 11.01 squared. So then b squared is equal to 11.01 squared minus 5 squared. And you just work this out, take the square root of both sides, and you'll get b is equal to square root of 11.01 squared minus 5 squared. Let's work that one out real quick. 11.01 squared minus 5 squared gives us 96.22. And if we take the square root of that, we get 908.1. Does that make sense? Oops, that might have not been 908. Let me double check. 980. My apologies. 980. So notice what I did right there. And this is for all my people out there that maybe struggle with getting the numbers wrong, making little errors. Check yourself. Just say, hey, did something go wrong in this process? Let me just check. I knew I had a tendency of writing this wrong. I feel like I even said something different. And I was like, let me check. So that's fine. It's good to go back and check. That's probably the best skill you can have, to check your work. That's going to be especially good if you're a doctor, engineer, lawyer, anything you do that requires you to not make mistakes. Okay. So basically, all those problems are going to be they're going to have a very similar structure. You're going to set it up, work it out. You're going to end up running into word problems. Okay. So in trigonometry, you've kind of gotten used to solving any kind of triangle that they throw at you. But now you're going to get word problems. It's not going to be straightforward. They're not going to tell you, oh, the hypotenuse is this, the adjacent angle is this. They're going to tell you in a more practical way. They're going to say, Sally was flying her kite and it got stuck on a tree. She knows her string is 30 yards long. And she basically tied down this to a rock. And she pulls out her stethoscope and figures out that this is 30 degrees up. How tall is the tree? And he's like, well, that's not clear. What kind of angle am I supposed to do? What am I supposed to do with this? So remember, there's only these things require 3 points. You need two. They gave you two. The hard part is identifying that the string is going to be the hypotenuse in this case. That's the tough part. The next part, you already got the angle. You're good. The hard part is identifying that they said how tall is the tree. This is what they're asking for right here. Okay, and so if they're given that, you bust out the same thing. You make your triangle. You're like Sokotoa. All right. And so what do we have? We have our angle, we have our hypotenuse, and we have opposite. What does that mean? You bust out the signs. Okay. So it's opposite y over adjacent. We're going to solve for y by multiplying 30 on both sides. And so then you're left with y is equal to 30 times sine of 30 degrees. Sine of 30, I just happen to know, is 1/2. 1/2 times 30 is 15. Okay? There's going to be plenty more word problems you're going to run into. All right? This is one of several of them. There's a lot of neat things you could do kind of using these relationships. Okay. The next thing we want to tackle, okay? This is important. This is another part that's going to be key that you're going to run into in your exam. It's going to be the 30, 60, 90 triangle relationship, okay? So the big part about this is just that it's a simple starting point that will give you that it's a reference point that is going to give you so much information. It's just going to be beautiful, okay? The if we assume the hypotenuse is just equal to 1 just to make it nice and in a nice way. I happen to know that the opposite of the 30 degrees is going to be 1/2. Okay. And if you can remember this, you can solve for this one. How can we solve for it? Pythagoras theorem, right? You have 1 squared is equal to, we'll call this x, 1/2 squared plus x squared. If you work this out, you're going to have 1/4 plus x squared. You can subtract 1/4 from both sides. You get 1. So 1 squared is 1 minus 1/4 is equal to x squared. Okay? The next thing you do is you're going to take the square root of both sides. But I guess before that, we want to do 1 minus 1/4. You have to have a common denominator. So you can multiply 4 on top and bottom of 1. So you can always divide by 1 and it's the same thing. 4 over 4 minus 1/4 is equal to 3/4. If you take the square root of 3/4, this is the same as the square root of 3 divided by the square root of 4. Hey, what's the square root of 4? 2. So this is going to give us that x is equal to the square root of 3 over 2. Teacher's probably shown you that. This is a quick way to kind of remember it. Remember the one opposite of 30 is 1/2 of the radius? Then you should be able to figure this out. So this is the 30, 60, 90 triangle. You got 1, you got 1/2, you got square root of 3 over 2. Okay? The beautiful part about this, in terms of giving you a reference point, is that now you have quick and easy access to some values. So sine of 30, SOHCAHTOA, I'm going to keep writing this, driving it home, okay? SOHCAHTOA is sine, is opposite over hypotenuse, cosines adjacent over hypotenuse, tangent is opposite over adjacent, okay? Opposite over hippo, okay, hypotenuse. This is going to be 1/2 over 1. If you divide anything by 1, it's the same thing, so it's 1/2. See, I use that over here in this problem. So now if we look at cosine of 30 degrees, that's going to be this one over that. Adjacent over hypotenuse. It's going to be square root of 3 over 2. Now what's tangent of 30? That one's going to be opposite over the adjacent. So when you have fractions and you're dividing them, remember you do keep, change, flip. So you take this one. First I'll write it in this other form. Any fraction is actually division, in case you forgot. So whenever you're dividing a fraction, you're going to do keep, change, flip. The first one you keep. The second one you change and you flip it. You can have 2 over the square root of 3. These, so when you multiply fractions, you multiply them straight across. 1 times 2 is equal to 2. 2 times square root of 3 is 2 times square root of 3. This is, you could cancel the 2's out. You're going to be left with 1 over the square root of 3. You can multiply top and bottom by 3, square root of 3 if you'd like, giving you the square root of 3 over 3. Square root of 3 times the square root of 3 is equal to 3. Okay? And so here's another thing that's neat. I know we didn't flip the orientation, but this gives us more information. What is the opposite of 60? It's going to be this. Okay? So if we, given that, we can now do the sine of 60. Opposite is this. Square root of 3 over 2. Remember, it's and then over 1. Then we can redo this whole process. What's the cosine of 60? It's adjacent, 1/2. So you see, we have many values now. We can do the same thing, tangent of 60. So with the tangent of 60, we do opposite over hypotenuse. So I'm going to skip the work, but I challenge you to do the same thing here. Get used to those fractions, dividing fractions. It's going to be helpful, okay? It's the square root of 3, okay? This is approximately 1.7, I believe. Maybe 1.8. Let me see. 1.73. Yep. Okay. And so then that's how that goes with the triangles. The 60, 90, 30, 60, 90 triangle. Okay. There's one more triangle that's going to be fairly important as well. That one is going to be the 45, 45, 45 triangle. Okay. Again, if we make this 1, what's interesting is this is an isosceles right triangle, which means they have the same side length. So if we did x on both of these, if we did Pythagoras theorem to solve this, we get x squared plus x squared is equal to 1 squared. This x plus squared plus x squared is equal to 2x squared. You then divide both sides by 2. Remember that 1 squared is 1. You're left with x squared is equal to 1/2. Take the square root of this. You get x is equal to the square of 1/2. This is the same as 1, the square root of 1, and the square root of 2, which is 1 over the square root of 2. This, you could also multiply top and bottom by the square root of 2 to get this. Square root of 2 over 2, square root of 2 over 2. So now you repeat this whole process, giving you whole new values. Sine of 45 degrees is equal to square root of 2 over 2. Cosine of 45 degrees is equal to the square root of 2 over 2. Tangent of 45, you can imagine it's this divided by this. I leave this as an exercise for the reader. Do this process again, you'll see that it's just equal to 1. Okay? Yeah, and so that's how you do the 30, 60, 90 triangle and the 45, 45, 90 triangle. So now that we've covered the different quantities of the 30, 60, 90 triangle, 45, 45, 90 triangle, we saw that sine of 30 is equal to 1/2, cosine of 30 is square root of 3 over 2, and all of these respective values. We're going to try to put them on a unit circle, okay? It's something I like to start drawing that's crucial to this, okay? So I'm going to draw a unit circle. What that means is my radius is equal to 1. And so if we look at this on a coordinate point, this is my point xy, okay? It's going to be anywhere on here. We basically inscribe a right triangle, and this side is going to be y, and this distance is x, okay? Now, the thing to consider is if we were to plot these points, we are basically going to get, it's very similar to how we did it above. I'm going to draw another one. Okay. Now our angle is going to be from here. So if we did our angle here at 30 degrees, and I said, hey, what's the sine of 30? Remember, that's just y. So this coordinate point, it's actually going to be square root of 3 over 2 and 1 half. Any point on here is actually going to be cosine of theta, sine of theta. Because of the relationship that we have with this is going to be theta. This is going to be the point x and y. Remember, keep in mind, what's the equation for cosine, for sine of theta? It's going to be y over r. If r is equal to 1, this is just y. Same thing with x. Cosine theta is equal to x over r. Remember, r is equal to 1, so this is just x. Remember, these are unit circles. Okay? And so, given that, here at 60 degrees, you're going to have sine of 60. Let's go back up here. We solve sine of 60 to be the square root of 3 over 2, and cosine of 60 to be 1 half. And right here, at 45 degrees, we did square root of 2 over 2, square root of 2 over 2. And so at 0, so now these are the points we don't really consider. If this is a unit circle, what is the coordinate point in here? I don't even have to tell you. It's 1 in x, 0 in y. What does that mean? That means cosine of 0, so it's the y coordinate, not cosine of theta, cosine of 0. So I'm plugging a 0 in here. That's equal to 0. It's y coordinate. Cosine of 0 is equal to 1. Now I hope you never forget. Okay? And we do the same thing here for 90 degrees, right? What coordinate point is this? X is 0, y is 1. 0, 1. So now if somebody asks you, what's sine of 90 degrees? Well, that's equal to the y. It's 1. What's cosine of 90 degrees? That's equal to 0. It's x. Does that make sense? So now we could do the same with this one. What's the x coordinate? It's negative 1. The y coordinate, 0. Okay? So now we do the same thing. What is sine of 180 degrees? This is 0, right? Because it's the y. What's cosine of 180 degrees? Negative 1. Do the same thing here. But this one, the angle is 270. And so the next time we'll cover these negative portions. But if you could imagine this side, the x is going to be negative, and the y remains positive. Notice over here we had all x values and y values positive. Over here, our x values are going to be negative, and our y values are going to be negative as well in this quadrant. Over here, the x values are positive, and our y values are negative. I hope this was helpful. I think that's enough for now. If anybody is interested in learning more, just let me know in the comments, and I'll try my best to share my insight with this stuff. All right, take care and have a good night.